Okay, in this lesson, we are going to review the methods for finding the greatest common factor. At the end of this lesson, you should be able to say, I can find the greatest common factor of two whole numbers less than or equal to 100. Let's review what greatest common factor means. Greatest means biggest. Common means something that's shared by two or more items or groups. And factors are numbers that can be multiplied to get another number, or numbers that can evenly divide another number. So the greatest common factor is the biggest factor that is shared by two or more numbers. We discussed 4 methods for finding the greatest common factor, and those are the 4 methods we're going to review in this lesson. The first method is to create a list or Venn diagram. The second method is to find the greatest common factor using an area model. The third method for finding the greatest common factor is to use the prime factorization of the two numbers you're looking at. And the fourth method, which we did not talk about at great length, is creating a ratio and then simplifying. Let's look at the first method, list or Venn diagram. If I wanted to find the greatest common factor of 18 and 24, I can do this by creating a list of their factors or putting their factors into a Venn diagram. So if I wanted to find the greatest common factor of 16 and 24, I can do this by creating a list of factors for 18 and 24. 1 can go into 18, 1 times 18. 2 can go into 18, 2 times 9. 3 can go into 18, 3 times 6. 4 cannot evenly divide 18, neither can 5. But 6 can, and since it's already on my list, I know I'm done. Then I go ahead and write a list of the factors for 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. 5 is not a factor of 24. 6 is, and it's already on my list on the right side, so I know I'm done. Then I write out my lists. Okay? I look at my two lists and try to find the biggest number or the biggest factor that both of these lists have in common. And the answer is 6. That is the biggest number that is on both lists. Creating a Venn diagram is very similar. I would list the factors of 18 and 24. And then look at both lists and see what they have in common. Both lists have a 1, so I place it in the center of my Venn diagram. They both have a 2, so I place that in the center of my Venn diagram. They both have a 3, and they both have a 6. Once I've found all the common factors, I look at where my Venn diagram overlaps, and I see that the greatest common factor is 6. It's very easy to tell from a list or a Venn diagram what the greatest common factor is. However, if you miss a factor somehow, you may not get the answer correct. So you've got to be very careful to make sure you've got every single factor for each number before you decide what the greatest common factor is. The second method is to create an area model to find the greatest common factor of 12 and 8, for example. I would start this by using a piece of grid paper, and I would create an 8 by 12 rectangle. And I would look at this rectangle and say, what is the biggest square I can fit into an 8 by 12 rectangle? And the answer is an 8 by 8 square. Then I ask myself, can I fit another 8 by 8 square in this rectangle? And the answer is no. So I know that 8 is not the greatest common factor of 8 and 12, because 8 cannot evenly divide 12. So then I look at what's left over. And in this section I have a 4 by 8. And I ask myself, what is the biggest square I can create in this section? And the answer is a 4 by 4. Then I ask myself, can I create another 4 by 4? And the answer is, yes, I can. Since this completely fills in my rectangle, I know that a 4 by 4 square is the biggest square that I can create to completely fill in an 8 by 12 grid. Therefore, a 4 by 4, or therefore 4 is my greatest common factor. This method is really good when you want to visually see what the greatest common factor is. However, it cannot be used if you are trying to find the greatest common factor of more than 2 numbers. I don't need grid paper to find the greatest common factor using an area model. I can use subtraction. I draw a square or rectangle and label it 8 by 12. Then decide what's the biggest square I can fit in? 8 by 8. That covers the entire length, but the width it does not. What would be left over if I used up 8 spaces or 8 units of the width would be 4, and then the length would still be 8. Then I ask myself, what's the biggest square that can fit in there? The answer is 4 by 4, which leaves a 4 by 4 left over, and I know that the GCF of 12 and 8 is 4. The third method is to use the prime factorization to find the greatest common factor of 18 and 36. For example, I would want to create a factor tree for both 18 and 36. 18, and there are many ways to do this, I'm going to choose the factor of 2. 2 can evenly divide 18, so it's a factor of 18. 2 times 9 is 18. I'm going to circle 2 because it's prime, meaning that only 1 and itself can evenly divide that number. 9 is composite because it has more than 2 factors. 9 can be created by multiplying 3 and 3. Since 3 is prime, I'm going to circle them both, and I know I am done finding the prime, I'm done with my factor tree. Then I write out the prime factorization. I'm going to use this later, and I did not, if you notice, I did not use exponents to write the prime factorization. I could have, but it's going to be easier for me if I don't. 36 can be broken down into 4 times 9. Both of those are composite. 4 can be broken down into 2 times 2, And 9 can be broken down into 3 times 3. So the prime factorization of 36 is 2 times 2 times 3 times 3. I'm going to take both of my prime factorizations and I'm going to write them so they are right on top of each other. There's the prime factorization of 18. There's the prime factorization of 36. Then I look at these two lists and circle what they have in common. They have a 2 and then 2 3s in common. So 2 times 3 times 3 equals 18. So the greatest common factor of 18 and 36 is 18. And if you'll recall, we said that if the smaller number can evenly divide the larger number, when I'm trying to find the greatest common factor, that is the greatest common factor. So one of the numbers listed can be the greatest common factor. The fourth method, which we did not discuss at great length, is simplifying. If I wanted to find the greatest common factor of 24 and 36, I could create a ratio and then simplify that ratio. Both can be divided by 4. 24 divided by 4 is 6. 36 divided by 4 is 9. 6 and 9 can be broken down again. They have a common factor of 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Since this ratio is in simplest terms, I know I'm done. Then I go back and look at my work, and I look and see what numbers I used to divide my ratio. I used a 4 and a 3. If I multiply those two, I get 12. So the greatest common factor of 24 and 36 is 12. And it doesn't matter if I put the 36 on top or the 24. It also doesn't matter which numbers I choose or which factors I choose to divide both, as long as it's common. 36 divided by 2 is 18. 24 divided by 2 is 12. Both of these have a common factor of 2. 18 divided by 2 is 9. 12 divided by 2 is 6. And 3 is a common factor of 9 and 6. So I simplify once again. And I notice that my ratio is in simplest terms, so I'm done. I go back and look at my work. I divided by 2, then 2, then 3. So if I multiply these, 2 times 2 is 4, 4 times 3 is 12, and I figured out just slightly different that the GCF of 24 and 36 is 12. Let's review the 4 methods for finding the greatest common factor. You can find the greatest common factor by creating a list or Venn diagram, by creating an area model, by finding the prime factorization of both numbers, and by creating a ratio and simplifying. You can go back and watch this video as many times as you need to, or rewind just to the parts that you need to hear again. When you are done, don't forget to WSQ in your notebooks and complete the worksheet that was given to you during class.